welcome back to page 4 of the midterm review packet for Algebra 1. Alright, let's get started with number 22. Solve the equation below. Now, looking at this equation, we have two sets of parentheses on either side of the equal sign. The one thing that makes this question look a little bit awkward and maybe more difficult is the fact that we have a fraction as the coefficient to one of our parentheses. We're going to talk about how we're going to distribute that out, but let's start with the parts that we know. So we're going to start by multiplying the negative 4 to both terms inside of the parentheses. So we're going to have negative 4x, and negative 4 times 5 is negative 20, equals. Now, 5/3 is going to multiply to 3x, and it's going to multiply to negative 12. Let's do one at a time. So let's start with 5/3 times 3. Okay, so 5/3 times 3x. 5/3 times 3. When we do that, we're going to put the whole number over 1, and we're going to multiply across. So 5 times 3 is 15. 3 times 1 is 3. 15 divided by 3 is 5. So here we have 5x as the first term. Now 5/3 times negative 12. Put the negative 12 over 1 and multiply across. 5 times negative 12 is negative 60. 3 times 1 is 3. Negative 60 divided by 3 is negative 20. Okay, so we have 5x minus 20. Now, this is much simpler, and we can go ahead and we can solve. So let's start by bringing over the negative 4x to the right-hand side. So add 4x to both sides. So we have negative 20 equals 5x plus 4x is 9x minus 20. We're going to add 20 to both sides so that we can get the x's by themselves. Twenties cancel on the left. Negative 20 plus 20 gives us 0. 0 is equal to 9x. When we divide both sides by 9, the 9s are going to cancel, and 0 divided by 9 gives you, so I'm going to finish it over here, gives you 0. So 0 divided by any number will give you 0, and that's going to equal x. So in this question, x is equal to 0. So if you have a fraction in front of the parentheses, you can take it step by step and distribute out that 5/3 or whatever the fraction is to each one of the terms. Just make sure that if you're multiplying it by a whole number, you put the whole number over 1 so that you can multiply across. All right, let's keep moving. Number 23. Identify the domain and range of the following relation. Okay, so we're looking for the domain and we're looking for the range. Domain is another word for the x values. Range is the y values. Another word for domain is the input into a function. And the y values are the output. You'll also hear input x values and domain referred to as the independent variable. So the range, the y values, and the output are the dependent variable. They depend on what the function says to do with the x that you put in. All right, let's take a look. We have a bunch of coordinates. So our domain is going to be all of our x coordinates. So negative 4, negative 2, and 8. We like to write these in order. So for our domain, it's going to be in set notation, negative 2, which is the smallest, negative 4, fix that. That's not the smallest. Our smallest is -4. That's more negative than -2. -2, and then lastly 8. So this is our set notation. It's those curly brackets, and then you list out all of the x values. For the range, we have curly bracket, all of the y values, 1, 0, and -1. So that's our range. So we're going to start with -1, which is the smallest, 0, and 1. Close the curly bracket. So domain stands for all the x values that we've highlighted, and the range is all the y values. And that's it. Let's move on. Number 24. What is the range of the graph below? So remember, range is all of the y values that are for your graph or for your relation or for your function. So all the y values. Now, take a look at your choices A, B, C, and D. Notice that both A and B talk about the x values, not the y. So we're going to cross those out. Our range is about the y values. So now, looking at this graph, we want to think about what is the lowest y value that we have. Our smallest y value is going to be right here. That's the lowest point that we have. That lowest point is at -1, -2, -3. -3 is our lowest y value. And now this graph continues going up, so there is y values for every one of these points as I go up to here. This is the very top, the highest y value. There are no arrows on this particular function and on this picture, which would mean that it's continuing to go up or continuing to go down. It's very finite, has a starting lowest point and an ending highest point. So this highest point is located at 0, 1, 2. So we have y values everywhere from -3 up to 2. So if I pick point 1, a y value of 1, which is around here, this point right here on my picture is going to have a range value of 1. So anything between -3 and 2 would be part of the range for this graph. Now let's look at your choices, C and D. We have choice D, which says that the y values go between -3 and 2. So our answer is choice D. I want to make a quick example for you. If, for example, this graph continued to go up and had arrows at the end of it, that would mean that there's no highest point. It would continue increasing and increasing and increasing. So your lowest point would still be -3, but your highest point would basically be infinity. It would continue going up, 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 up. So to write the range of something that continues going in one direction, I'm not going to have a compound inequality. I'm just going to say the y values are greater than or equal to -3, because all these points are greater than -3. So it would be a y is greater than or equal to -3. So you have to make sure you pay attention to the end behavior of your graph. Are there arrows? Because the arrows mean they continue going up or continue going down. In this case, this graph will continue going up, but it'll also continue going more and more to the left because it's going at a diagonal. So it's going up and it's going more and more left. So keep that in mind. Let's move on to the next question. Number 25. If the following relation is a function, which ordered pair could be the fifth point? So if the following relation is a function, which of these ordered pairs could be the fifth point? We have 1, 2, 3, 4 points, and A, B, C, and D are choices for what could be the fifth point. Now remember, for every input, you can only have one output. That's the rule in order to be a function. So we cannot repeat our x values, -2, 0, 1, 5. We can't repeat them and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I can't repeat, for example, -2 and then give a different y value than it's already here. So I and have any other y value other than 7. So if I had negative 2, 4, nope, this would not be a function. Okay, so I can't repeat my x value and have another y value go along with it other than what's listed. So let's look at your first choice, A. It says x is 1. Well, I already have one that has a 1x value. It's supposed to map to negative 4. But here it's saying it should go to 9. That would not make it a function because the same x value goes to 2 different y values. We can't have that. Cross it off. For B, if I include 5 as my x value, I've already had that. It has to map to negative 2. But here it's saying it's going to map to 7. Well, that wouldn't make it a function then, because then the same input has 2 different outputs. Either it's 7 or negative 2. Can't have that. Take a look at C. 3 as my x value. I don't have 3 as an x value. So actually that would work. 3 can map to any point. In this case, it's negative 4, and I'm not repeating my x value with different outputs. So I like C. And then D, 0, negative 8. 0, I already have, and it says it should go to negative 8. But I already have it going to 3. So I can't have 2 different outputs. So I'm going to say no to D as well. My answer choice is C. Let's move on. Number 26. And this is an important one, so make sure you're paying attention. 26. Given the function below, which of the following values will result in f of x equaling 10? So you want to make sure that whatever you get, the function will equal to 10. Here's our function. F of x is equal to 1/2 x plus 8. Now, there's a really big difference between when we say f of x is equal to 10 and when we say f of 10. Now, when you see f of x is equal to 10, that means you're going to replace the entire thing on the left-hand side with 10, and you're going to solve that equation. When you see f of 10, that means you're going to take the 10 and you're going to plug it in wherever you see an x. So if I had f of 10, that means I'm going to do this. F of x equals 1/2 times 10 plus 8. And basically what I would be doing is I would be replacing x with 10 anywhere that x appears. So this is a big distinction. If you see f of x as equaling to some number, then you want to set your equation equal to that number that they're saying. If you see something in the parentheses plugged in, that's your x value that you need to substitute in your equation. So understand the difference between the two. It's very, very important. Okay, so let's take a look. In this example, they want f of x to equal 10. So that means I'm going to replace f of x with 10. That whole equation should equal 10. So I'm going to go ahead and rewrite this so that I can solve. 10 is equal to 1/2 x plus 8. So I'm going to solve for x. I'm going to solve for the input that would allow me to get 10 as an output. All right, so I'm going to subtract 8 from both sides. 10 minus 8 is 2, which equals 1/2 x. Now to get x by itself, to get rid of the 1/2, remember we multiply it by 2. That always gets rid of a 1/2. 1/2 and 2 will cancel. It'll multiply and give you 1, which we don't even have to write. And on the left-hand side, 2 times 2 is 4. So 4 is your x value. So what does this say? This says if you substitute 4 in for the x in your original function, you'll get an output of 10. Now take a look. Our answer choice is going to be choice C. So if I plugged in 4 into my function, I would get it equal to 10. Okay, so make sure you understand the difference between f of x is equal to some number and f of some number. Okay? In the first one, you're just going to set the whole equation equal to the number. And in the second example, you're going to plug in that number for x. All right? So make sure you understand the distinction between the two. Let's move on. 27. given the function below, if f of x is equal to -1, find the value of x. So we're looking to solve for x. You're not plugging anything in for x. You're trying to solve for it. So remember, f of x is equal to -1 means this -1 is the output. That's what you should set the entire equation equal to. So we're going to replace f of x with -1. So let's go ahead and do that. -1 is equal to 4x plus 11. And now all we have to do is solve for x. We're going to subtract 11 from both sides. This cancels. -1 minus 11 is -12 equals 4x. Divide both sides by 4. And so -12 divided by 4 is -3. And that is your x value. Rewrite it. X equals -3. Now, what does that mean? That means that if I did the function of -3, if I plugged in -3 for x, my output would equal to -1. All right, and let's just check that just so that you can see it. If I plugged in 4 times -3 plus 11, I should get -1 as my output. 4 times -3 is -12 plus 11 equals -1. -12 plus 11 is -1. So it does work. Okay, so again, in this one, they said that the function is equal to something. So that's when you replace that function notation with what it is equal to and solve. All right, let's move on. Number 28. Which graphs could represent a function? So which ones are functions? Okay, that you want it to be a function. Remember, when you have graphs, the way that we check if something's a function is by using the vertical line test. And you want to make sure that your vertical line does not pass through the graph, through the picture, more than once. If it does pass more than once, it is not a function. So let's take a look at the first one. So if I draw my vertical line here, I've cut through the graph once. If I draw it here, I've cut through the graph once. Draw it here, I've cut through the graph once. So no matter where I drew my vertical line, it cut through once. So yes, this is a function. So I am going to select this one. Next one, vertical line test. Here, I technically haven't passed through it at all, but I know that technically this line will continue and eventually I will cut through the line once. So it's okay. Let's keep drawing our vertical lines. So if I trace the y-axis, I've only cut through once. If I do another line, I've only cut through once. So no matter where I draw my vertical line, I will only cut through the picture once. So that means yes, this is a function. It passes the vertical line test. Let's go on to the next one. Vertical line here, I only cut through once. Vertical line here, I only cut through once. Even if I make one right at the end, I haven't technically cut in at all, and that's okay. The goal is that you don't go through more than once. So I'm going to say yes, this is also a function. All right, and the last one. I want you to notice, maybe it's a little bit hidden, but this is the line. It's a vertical line. So this line equation, just that you understand, we could bring back other topics. This is the equation x equals 3. That's the equation for that line. It's a vertical line, undefined slope, has an x equals equation, and it passes through 3 on the x-axis. Now, if I drew a vertical line here, I'm passing through this vertical line at 1,000,000 points, at an infinite amount of points. Here it's going to pass through, here, here, here. Basically, my vertical line is infinitely cutting through the picture that is there. So that means no, this is not a function because every x value has an infinite amount of y values that go along with it. Technically, the point down here is, let's see, 3, -2. And then the point at the top is 1, 2, 3, would be 3, 3. I can't have more than one y value attached to a single x value of 3. This is not a function. Okay? My vertical line will cut through more than once. It will cut through an infinite amount of times. Okay? They will be on top of each other. So not a function. But the first 3 are. So if this was a select all that apply, you'd pick the first 3. Okay, 2 more questions on this page. 29. If g of x equals 3x minus 2, find g of 8 minus g of -5. Okay, so what they want us to do is they want us to evaluate the function. They want us to plug 8 into the x value, and then they want us to plug -5 into the x value, and then take the difference. All right, so let's get this set up. Okay, notice these are going to be x values that we're going to be plugging in. So what we want to do when we have g of 8 minus g of -5, I'm going to go ahead and rewrite what they're wanting us to do so we can keep nice and organized. So g of 8 would be plugging into 3x minus 2, and we're going to be plugging 8 into 3x minus 2. Okay, and then for the other one, same thing. I'm going to be doing 3x minus 2 again, because we're using the g function. But I'm going to be plugging -5 into x this time. All right, so be very careful when we do this here. Plugging things in, I'm doing 3 times 8 minus 2. 3 times 8 is 24 minus 2. So we get 22. Here, 3x minus 2, I'm going to plug in -5. So 3 times -5 minus 2. 3 times -5 is -15 minus 2, -17. Now, remember what we had to do. We had to subtract g of -5. So we're subtracting -17. So notice when we're subtracting a negative, we're going to get a positive. So this is really 22 plus 17. Let's go ahead and work that out. 22 plus 17. 2 plus 7 is 9. 2 plus 1 is 3. So our final answer is 39. You have to be very careful when you have a negative, when you're subtracting a function. Okay? Be very careful. All right, let's move on to the next question. Number 30. Which function has values of f of 9 equals 3 and f of 2 equals -18? Okay, now what does this mean? This means that if I plug 9 into the function as my x value, as my input, then I should get 3 as my y value, my output. If I plug in 2 into that same function, so 2 as my x value, then I should get -18 as my y value, whatever's getting output. So what you're looking at for each one of these choices is you want to see, if I plug in 9, do I get 3 once I work out the expression? So let's start with A. You're going to have to work out each one of these and see if it works. So for A, f of x equals -3x plus 11. So if I plug in 9 for x, I should get an output of 3. So if I plug in 9, so I'm going to plug in 9 for x plus 11. Let's see, let's work this out and see what we get. So f of 9 equals -3 times 9, which is -27, plus 11. So f of 9 equals 16 negative. So that's not what we want. We want f of 9 to equal 3, not negative 16. So automatically, I already know that A is not the correct answer. When I put an input of 9, I don't get an output of 3. So I'm not going to choose choice B. Choice A. Let's go on to choice B. Okay, so now let's start this again. If I do for choice B, if I plug in to f of x equals negative 2x plus 10, I want to see what I get. So f of, same thing, I'm going to plug in 9, equals, let's go ahead and plug in 9, negative 2 times 9 plus 10. My hope is that I get 3. Let's see what I get. Negative 2 times 9 is negative 18 plus 10. F of 9 equals negative 18 plus 10 is negative 8. Not what I want, so I'm not choosing choice B either. Let's go on to C. C says f of x equals negative 3x plus 25. So let's go ahead and we're going to plug in 9 for the x value. So f of 9 equals negative 3 times 9 plus 25. F of 9 equals negative 3 times 9 is negative 27 plus 25. So f of 9 equals a negative, and then 27 minus 25 is 2. Okay, we're getting closer to 3, but definitely not choice C. Let's hope that choice D works. Otherwise, we probably made a mistake somewhere. So I'm going to clear this off. And you do require a lot of paper for this one. Choice D. F of x equals 3x minus 24. We're plugging in 9 to see if we get 3. F of 9 equals 3 times 9 minus 24. F of 9 equals 3 times 9 is positive 27 minus 24. 27 minus 24 gives us f of 9 equals 3. So yes, I do get the first part. I like it. But I need to check that f of 2 gives me negative 18. So one more time. Now we're doing f of 2. And we're plugging it into 3x minus 24. So 3 times 2 minus 24. F of 2 equals 3 times 2, which is 6, minus 24. F of 2, I'm going to get a negative because 24 is larger than 6. And now 24 minus 6 is negative 18. And that's exactly what we wanted to get for the second input of 2. So it works for both inputs. When you input 9 or when you input 2, you get the corresponding output that they wanted. So the answer is choice D. Okay, so this was really good. Number 29 and 30 are really good practice problems for you to understand the difference between f of x or f of x equals some number. Okay, let's move on to the next page.